Hi everybody, this is day 5 of the semester 1 final exam review for geometry. Alright, so let's take a look at this first problem. So this asks us to find the range of the possible values for angle ACD. So that's going to be this angle right here, and I'll call it X. So we know that the exterior angle, and this is the exterior angle, is always going to be larger than either of the remote interior angles, so either here or here. So we know that X must be greater than 81. But we also know that there is going to be a maximum value that it's going to have, so that value will never be more than a straight line. So you could see that it could extend more, but it won't go past a straight line. So we know that X will never be greater than 180, so X is less than 180. And the way you write this is 81 is less than X is less than 180. So it's essentially saying that the angle is between 81 and 180. Okay, so here we have a triangle, and it says in the figure, BD is an altitude. So if you remember what an altitude does, an altitude creates a 90-degree angle, or a right angle. So since BD is an altitude, we know that both of these are going to be 90 degrees. And that's all that we can tell just from the word altitude, so that's the only thing that an altitude does. Now, we also are told that angle BCD, that's right here, is 3x plus 4, minus 4. And we are told that DBC, that's right here, is 2x plus 9. So they would like us to find the measure of angle DBC. So in order for us to find DBC, we first need to find X. So we can create an equation based on our triangle sum theorem, because we know that the three angles should add up to 180. So we have 2x plus 9 plus 3x minus 4 plus 90 equals 180. And I'm going to subtract 90 from both sides. This is also an equation you can create immediately. If you have a right triangle, the other two triangles are always going to add up to 90. So whether you want to add them all up to 180 or take the other two and set them equal to 90, it's completely equivalent. Now let's combine like terms, and then we'll finish solving. So we get x equals 17, but remember they don't want us to find x, they would like us to find the measure of angle DBC. So we know that angle DBC is equal to 2x plus 9, so we're going to do a little substitution. We know that x is equal to 17. So now we just need to simplify. 34 plus 9, so angle DBC is going to equal 43. And then we'll put degrees because it is an angle. All right, let's take a look at this next problem. This says list the sides of the triangle from shortest to longest. So remember the sides, we can figure out the order of the sides by looking at the order of the angles. So the shortest side is always going to be opposite the smallest angle. So we'll start with our smallest angle, which is 50, and we'll look across, and that's going to be our shortest side. So side CA or AC. Then I'll find my next smallest side, angle, which is 60, and I'll look opposite. So the next largest side would be side BC or CB. And then the largest angle is always going to be opposite the longest side. So our longest side is AB or BA. There you have it. Okay, this problem asks, what is the transformation that occurs from the point 5, negative 3 to -5, -3. So remember, a transformation is just a type of change. And there's different types of transformations that we've talked about. So if you compare our old or our original point to our new point, a to a prime, you'll see that the only thing that changed was that +5 became -5. So we know that if something is changing signs, it's going to be some type of reflection. Oops. So there were two types of reflections that we talked about. We talked about a reflection over the x-axis, and we talked about a reflection over the y-axis. So remember, if you are reflecting over the x-axis, you are taking the opposite of your y value. You're multiplying the y value by -1. And if you're reflecting over the y-axis, you are multiplying the x value by -1. So since we were essentially taking our x value, which used to be 5, and multiplying it by -1, notice that the y value stays the same. Our answer is going to be a reflection over the y-axis. But make sure you know the difference between those two types of reflections. Okay, so this problem says if BD is a perpendicular bisector, what true statements can you make about the figure? So let's talk about what a perpendicular bisector does. So a perpendicular bisector does two things. So the one thing that it does is it creates a 90-degree angle, which is why it's called perpendicular. And then the other thing it does is it creates two congruent line segments, which is the bisector part. So remember, a bisector cuts things in half. So here's BD. So since it says the word perpendicular, we can draw in our 90-degree angles. And since it says bisector, I can say that these two segments are congruent. So what true statements can we make about this figure? Well, we can say that angle ADB is equal to 90 degrees. We can say that angle CDB equals 90 degrees. And the last true statement we can make is that line segment AD is congruent to line segment DC. So remember, a perpendicular bisector does not bisect your angle, it bisects the opposite side. Okay, so here we are asked to compare the lengths of line segments AD and DB. So we're going to compare AD, which is right here, with the DB, which is right here. So here you'll notice that we have a scenario where we have two congruent sides. We have this side, let me do it in pen, this side is congruent to this side because they're both 5. And then that middle angle, or that middle line segment, is shared by both triangles, so it's congruent to itself. So when we have a situation where we have two sides of a triangle that are congruent, we can use the angles to compare the sides. So if you look at AB, it is opposite the angle 27 degrees. And if you look at BD, it is opposite the angle 28 degrees. So we know that 27 degrees is less than 28 degrees. So that means AB, which corresponds with 27, is less than BD or DB. So remember, when you have a scenario where you know that two of the sides are congruent between two triangles, you can compare side lengths or angles using their corresponding side lengths or angles. Okay, so this problem says if you start at the coordinate B, which is -3, -12, and you translate the coordinate according to the rule xy becomes x minus 5, y plus 2, what is the new coordinate? So remember, when they ask you to translate something, you are simply shifting your coordinate left, right, up, or down. So you're taking your point and you're simply moving it side to side or up and down. You're not actually changing anything about the figure, like the shape of the figure or the orientation of the figure. So we're just going to simply take our original value, which is -3, -12, and we're going to follow the rules. So the rule says to subtract 5 from the x values and to add 2 to the y values. So now this is going to become b prime, which will be -8, -10. So remember, what we're actually doing here is we are shifting left 5, because anything done to your x value is going to move horizontally, which is left or right. And then here we're actually going up 2, because anything done to your y value is going to move your coordinate vertically. So our final answer is just our point shifted to the left 5 and up 2. Okay, this problem says to describe the following types of transformations, which remember are just changes. So just kind of talking about what it does. We just talked about translation. A translation is just a shift up, down, left, or right. But remember, it doesn't change like which way your figure is pointing. It doesn't change the orientation or the distance between any of the points. So a reflection flips the figure or the graph over a line. So it might be upside down or it might be mirror imaged, but the actual shape of the graph is maintained and the distance between the points is also maintained. So a rotation is when you move the figure around a given point. So this once again will change the way that your figure is facing. It might change which quadrant it's in. However, it won't change the actual shape of your graph. It's just moved in a different location and it's kind of pointing a different direction. Now a dilation we like to think of as a stretch or shrink. So this is the only one that really changes the shape of your graph. The distance between the points will change because your figure is either getting larger or it's shrinking down and becoming smaller. So the shape of the figure looks the same, but the distance between the points is either going to be bigger or smaller. Okay, so this problem we're asked to order the angles from least to greatest, and remember least means smallest, and greatest means largest or biggest. So remember, we can order our angles by looking at the opposite sides. So we're going to start with our smallest side, which is going to be 7, and I'm going to look opposite of that, and that's going to be our smallest angle, which is angle O. Then I'll find our next smallest side, which is 13, and we're going to look opposite of that, and that is going to be angle G. And then our largest side is going to be opposite of our largest angle, which will be angle E. And we're done. Okay, we have 2 more for you. It says the following is a map that shows the distance and angles between the grocery store, which is G, the movie theater, which is M, and the hospital, which is H. Which 2 locations have the shortest distance between them? So remember, we can figure out the lengths of those different lines by comparing the angles. But first, we need to be able to find x, so then we can figure out how big each of those angles are. So we're going to start by creating an equation using our triangle sum theorem. All of the angles should always add up to 180 degrees. So from here, we can combine like terms. So we get 16x, and then we can combine like terms here. Okay, then I'm going to subtract 20 from both sides and then divide by 16, so I get x equals 10. So now that we know x, we can find the angles. So I'm going to substitute it into each one. So we know that angle H is 3x plus 22. So we're going to substitute x with 10. So we have 30 plus 22. So we're going to get angle H equals 52 degrees. Now we're going to do the same thing for angle G. So let's substitute straight away. 5 times 10 plus 8. So angle G equals 58 degrees. And for angle M, we have 8 times 10 minus 10. So angle M is going to be 70 degrees. So now let's go back and look at what they're asking again. They ask us to find which two locations have the shortest distance. So we're essentially looking for the shortest line segment. And we know that the shortest line segment can be found across from the smallest angle. So I'm going to look at angle H, which is our smallest angle, and then we're going to look across. So then we have the shortest side. So GM. And that represents the distance between the grocery store and the movie theater. So those are the two locations that have the shortest distance between them because the line segment between them is the smallest. All right. Oh, that was all for today. Thank you for watching the last day of the geometry final exam review.